Hello dear friends, I welcome you again in my class. So last time we were discussing about polypeptides. Polypeptides, proteins and oligopeptides. And we discussed about these are short chains of peptides. These are long chains of peptides. In case of polypeptides, it contains long chains of peptides, and in case of proteins, it contains more than 100 alpha amino acids. And the molecular mass of those amino acids is more than 10,000. So this was the main difference between polypeptides, proteins and oligopeptides. Then we discuss about the characteristic properties of peptides. We know that if we see the nomenclature, it starts from terminal N to terminal carboxylic group. Then we discussed about properties that they have same isoelectronic point, which help us in separation of peptides, okay, and many other things. Today we will discuss about what is the classification of proteins. Based on molecular mass, there are two types of proteins. Based on molecular mass, there are two types of proteins. One is fibrous protein. Second one is globular protein. So we will discuss them one by one. First one is fibrous protein. इसमें क्या होता है, जो प्रोटीन मॉलिक्यूल्स होते हैं वो थ्रेड लाइक ऐसे रहते हैं, थ्रेड लाइक टू फॉर्म थ्रेड लाइक स्ट्रक्चर्स which form fibers. Like fibers, they remain in linear shapes to form fiber type structure that is known as fibrous protein. अब उसके बाद क्या होता है, जो इनकी स्टेबिलिटी या जो इनकी स्ट्रेंथ कैसे बढ़ती है, वो क्या होता है, पॉलीपेप्टाइड चेन जो होते हैं या पॉलीपेप्टाइड्स होते हैं, वो इन फाइबर्स को बहुत जगह ऐसे जोड़ते हैं बाय हाइड्रोजन बॉन्डिंग, रिजल्टिंग इन स्ट्रेंथ ऑफ दीज प्रोटीन्स. And moreover, due to this hydrogen bonding, these proteins are insoluble in water. One important thing about these proteins is that they are least active against temperature, that is moderate temperature and pH. With moderate change in temperature and pH, they don't change their original structure. अगर हम देखेंगे जो fibrous protein होते हैं, ये कहाँ होते हैं? Most of the animal tissues are made up of animal tissues, or the structural formation of animal tissues is made up of fibrous proteins. Okay, example, keratin in skin, nails and wool. Okay, collagen in silk, tenderness, sorry. Fibroin in silk, and last one is myosin in muscles. So these are the tissues which are made up of this type of proteins. These tissues contain these proteins. Second one is globular protein. So first if we see the structure of fibrous protein, so it is like this, linear threads. It form linear threads, but the polypeptide chains in many carbons or in many points it form hydrogen bonding like this. Okay, hydrogen bonding which help us in the strength of these proteins, and second one is that they become insoluble in water, hydrogen bonding. Second one is globular protein. The polypeptide chains, whether they are one chain or many chains, they surround themselves in such a way so that the structure of protein is like spheroidal. It means that spherical, and this type of protein is known as globular protein. अब ग्लोब्यूलर प्रोटीन जो होता है, इसकी कैरेक्टरिस्टिक प्रॉपर्टी क्या होती है, हमारे पास क्या होता है, प्रोटीन जो होते हैं उसमें दो एंड्स होते हैं, या उसमें क्या होता है, जो लिपोफिलिक एंड होता है या लिपिड लविंग एंड होता है, वो क्या होता है, वो वाटर वो उसमें क्या होता है, वो वाटर मॉलिक्यूल में अंदर, यहाँ जो प्रोटीन होता है सुपररेडिकल होता है उसके अंदर जाता है ऐसे. इफ दिस इज द मॉलिक्यूल, इफ दिस इज द प्रोटीन मॉलिक्यूल. अब जो हमारे पास हमने ग्लोबुलर प्रोटीन पढ़ा है कि ग्लोबुलर प्रोटीन जो होता है उसमें क्या होता है, the polypeptide chains are arranged in such a way so that they form a spherical shape like this. उसमें क्या होता है, जो पॉलीपेप्टाइड चेन का नॉन पोलर पार्ट होता है दैट इज लिपोफिलिक. लिपोफिलिक मीन्स लिपिड अट्रैक्टिंग और नॉन पोलर पार्ट. इट कम्स इनसाइड, एंड जो हाइड्रोफिलिक पार्ट होता है वो बाहर होता है. इट इज एक्चुअली पोलर पार्ट. फिर क्या होता है, जो वाटर मॉलिक्यूल हमारा यहाँ बाहर होता है, इट विल शो डाइपोल इंटरेक्शन विद द पोलर पार्ट दैट इज हाइड्रोफिलिक पार्ट ऑफ दैट वेरी ग्लोबुलर प्रोटीन. So these proteins are highly soluble in water. Besides this, they are very much prone to either pH and the temperature. Okay. Structure. So this was all about fibrous and globular protein. अब कहाँ हो सकता है globular protein? All enzymes are made up of globular protein. All enzymes are made up of this protein, and certain hormones like insulin in pancreas. Okay, similarly thyroglobin in thyroxine form which is soluble in water. Okay, similarly antibodies which are against allergies or outside agents, they are made up of these proteins. Similarly there are some other components like hemoglobin which help us in the oxygen transfer from blood to muscles. This is made up of this protein, that is globular protein. Similarly fibronectin which changes the shape into insoluble form, that is fibrin, which help us in the clotting of blood. So these all proteins are made, these all bodies are made up of this protein. So this is the basic application of fibrous or globular protein in biological system. So we discussed about, in short, we discussed about based on molecular structure there are two types of proteins. One is fibrous protein and second one is globular protein. In case of fibrous proteins, the proteins make long chains to form fibers, and there is intersection, or there are hydrogen bonding between them, resulting in strengthening of that very fibrous protein, but they are insoluble in water. All enzymes are made up of this. And second one is globular protein. The structure of globular protein is spherical. So the examples are here. And what is the bonding in globular protein? अब मसला क्या है, globular protein ऐसे बन गया, पॉलीपेप्टाइड चेंजेस बनते हैं, अब आपस में ये इंटरेक्शन करते हैं जैसे फाइब्रस प्रोटीन में था। लेकिन कौन कौन से इंटरेक्शन हो सकते है, उसमें इंटरेक्शन हो सकती है पहले हाइड्रोजन बॉन्डिंग, सेकेंड वन इज डाइसल्फाइड बॉन्डिंग, थर्ड वन इज वैन डर वाल्स इंटरेक्शन, and fourth one is dipole-dipole interaction. So these are the interactions possible which resulting in the shape of this as superiodyl. This is hydrogen bonding, disulfide bonding, van der Waals interaction, and dipole-dipole interaction. So this was all about classification of proteins based on molecular structure. Thank you for your cooperation.